For the past 2 years, the core skill in working with AI was writing a better prompt. Type the request, read the answer, spot the mistake, type again. That era is closing. The frontier has moved from the prompt to the loop, from telling a model what to do once to designing a system that tells itself what to do over and over until the goal is actually met. This is loop engineering, architecting systems that prompt themselves. Over the next few minutes, we'll build the blueprint, what a loop actually is, the components it runs on, the architectural patterns that make it reliable, and the failure modes that show up when the machine gets very good at working without you. Here is the shift in one picture. In the old model, prompting, you are the wire in the circuit. A human types, the agent types back, the agent hits an error. The human reads that error, copies it, and pastes it back in. You are the retry mechanism, and every single iteration costs you attention. In loop engineering, that wire is replaced by a control system. An automation trigger fires, the agent takes action. Something verifies the output. The system adjusts and runs again until the objective is met. Peter Steinberger put it bluntly, you should be designing loops that prompt your agents. And Boris Cherny at Anthropic said, I don't prompt Claude anymore. My job is to write loops. The leverage point has moved. We are shifting from single-shot prompts to autonomous control systems. Let's make that concrete across 4 dimensions. Initiation. Manual prompting starts when a human types in a chat window. A loop starts on a cron job, a webhook, or a CI event. No human is required for the system to wake up. State and memory. Manual prompting lives inside the context window, which fades. A loop relies on persistent external files, a state.md file, or a linear board that outlive any single session. Quality control. Manually, you are the reviewer, reading the diff and running the tests. In a loop, a verifier subagent does that job through a maker-checker split and failure mode. Manual prompting hard stops and waits for you. A loop retries, revises its plan, or escalates to a human deliberately as a design path rather than a dead end. It helps to see this as a stack because each layer stands on the one below it. At the foundation, prompt engineering, a single turn, a manual instruction. Necessary, but nowhere near sufficient. Above that, context engineering, retrieval, tool access, autonomous data gathering, making sure the model has the right information in front of it. Above that, harness engineering, the environment the agent runs in, the runtime, the sandbox, external state management. This is where most serious agent work lives today. And on the top floor, loop engineering, orchestration, recursion, triggers, and self-prompting. Loop engineering sits one floor above the harness. It doesn't just hand the agent a good environment. It pokes the agent on a schedule, spawns helpers when the work demands them, and feeds the agent's own output back in as its next instruction. So what is a loop precisely? A loop is a self-sustaining goal-driven control system. It discovers work, acts on it, verifies the result, and persists state. 6 components make that possible. Automations are the heartbeat, cron schedules, or a loop command firing the cycle. Work trees provide isolation, so parallel agents don't collide in the same files. Skills are codified project knowledge written into a skill.md file so the agent doesn't rediscover your conventions on every run. State is the spine, markdown or a linear board holding what is true right now. Connectors, through MCP plugins, give the loop real tools instead of suggestions. And subagents separate ideation from verification. Leave any one of these out, and the loop will stall, collide with itself, or quietly drift off target. This is the single most important structural rule in the whole blueprint. Never let an agent grade its own homework. Split the work in 2. Agent A is the maker. It writes the implementation and attempts to push. Agent B is the verifier. It evaluates that work against a rubric, your skill.md conventions, plus the CI tests. On approval, the change lands on the main branch. On rejection, it goes back for a retry with the reason attached. Why the split matters. The model that just wrote the code is the worst possible judge of whether that code is finished. It is already convinced. A fresh model with a clean context and an explicit rubric is the only thing that can honestly decide whether the stopping condition has been met. Unattended loops make unattended mistakes. Subagents are the only reason you can walk away from the loop. Now the hard part, memory. Agent sessions end. Context fades. Session 3 does not remember what session 1 learned, so you stop storing the important things inside the model and start storing them outside it in what we can call the memory spine. Every session writes state to it and reads state from it, a state.md file, a loop-state.json, a linear board. Whatever your team already looks at, without a persistent external spine, every loop run is day one. The agent rederives what it already knew, repeats a fix that already failed, and asks you a question you already answered. Good state answers 3 questions on every read. What are we doing? What failed last time? And what is currently waiting on a human? The model forgets, the repository doesn't. Not every loop should have the same shape. 3 patterns cover most of what you will build. Pattern 1, the retry loop. Action, then check, and on failure, retry. Tight and simple. Best for atomic tasks. Make this one test pass. Fix this one type error. Pattern 2, plan, execute, verify. Plan first. Execute a single step, verify that step, then move to the next, repeating n times until the work is complete. This is what you want for multi-step refactors, because verifying each step stops small errors from compounding into a mess 10 steps later. Pattern 3, explore and narrow. Start from a hypothesis, fan out across several parallel paths. Compare the results, then select and refine the winner. Best for debugging an error you don't understand yet or exploring an unfamiliar API. Match the pattern to the task. Now stack them. Real systems run loops nested inside loops. At the center sits the agent loop, a model calling tools until a task is done. Wrap that in a verification loop, which grades the output and retries with feedback. Wrap that in an event-driven loop. Cron jobs and webhooks that scale the agent from something you invoke into something that simply runs in the background. And wrap all of it in a hill climbing loop, an engine that analyzes traces from past runs and rewrites the inner loops to make them better over time. That outermost ring is the ultimate leverage point. The return arrow doesn't just send control back to the top of the same loop. It reaches inside and rewrites the agent's configuration, its prompt, and its tools. The system stops repeating itself and starts improving itself. None of this is limited to code. Take a growth loop, a monthly or weekly cron fires. The loop analyzes, pulling data from the search console and adds APIs. It runs an experiment, generating new copy and new tags. It deploys that to production. Then it waits 30 days and measures the objective metric, rank, clicks, conversions, and that measurement becomes the input to the next cycle. The same skeleton works for support triage, financial reporting, competitive monitoring, or content pipeline. What you are looking at is the lean startup build. Measure, learn cycle, executed end-to-end by autonomous agents, optimizing against an objective verifiable metric. The constraint was never the quality of the idea. It was how many cycles a human team could afford to run per quarter. Now the uncomfortable part. Loops create 3 kinds of debt. Comprehension debt: the faster the loop ships code you didn't write, the wider the gap between what exists in your repository and what you actually understand. Intent debt: the loss of concrete rationale. Agents will fill any hole in your intent with a confident guess, unless the boundaries are explicitly codified in a skill.md file, in tests, in written constraints. And cognitive surrender: the comfortable trap of abdicating judgment entirely and accepting whatever the loop outputs, because it is usually right and checking is work. Here's the trap. A smooth loop makes that debt grow faster, not slower. The better it runs, the less you look. So the reading, the review, the architectural check-in, all of it has to be scheduled deliberately. The loop doesn't know whether you understand the work. You do. So the blueprint, automation, doesn't mean removing humans. It means elevating them to architects. Loops require 3 things to be safe: precise goals, strict tool budgets, and verifiable stop conditions. Miss any one of those and you haven't built a control system, you have built a very expensive infinite loop. And the leverage point has moved. Your job is no longer to press go. It is to design the system that presses go, checks the result, and decides what happens next. Companies that build learning loops early, where human judgment and token capital compound together, will build an advantage that is hard to replicate. build the loop, stay the engineer. If this was useful, subscribe for more on agentic systems and applied AI engineering. Thanks for watching.